This is Precalculus, section 1.4 notes, day 2. So we are going to continue talking about rational expressions, but today we are going to be talking about adding and subtracting rational expressions. Keep in mind, rational expressions are fractions, and we all know you need a common denominator to add or subtract fractions. So that is what today's lesson is going to be all about. We're going to start with reviewing how to determine a common denominator for rational expressions. A least common denominator is always nice and easier to use, but it's not necessary, okay? But it is preferred because it does make your work less in the end. The common denominator is going to be the product of the different denominators, using the greatest power that appears in each of the different factors and the least common multiple of the coefficients. So let's talk a little bit about that, okay? We're not actually going to do the addition here. We're just trying to determine if we were going to add these together, what would our common denominator be, okay? So our first denominator has got, let's see, it's an 8, it's an m cubed, it's an n squared, and it's a p, right? All that's being multiplied together. Our second denominator is a 12, an m to the fourth, an n to the first, and a p cubed. All right, so our common denominator then, we need a number that 8 and 12 both go into. So you could multiply 8 times 12, but that's actually bigger than it needs to be because there's a smaller number that 8 and 12 both go into, and that is 24. So I'm going to use 24 as part of my common denominator. Next, I'm going to look at my m's. My first denominator had m cubed, my second had m to the fourth, which means my common denominator has to have m to the fourth, right? The bigger one always determines what has to be in the common denominator. Same with the n's. I've got n squared and n to the first, so my common denominator has to contain an n squared, and I've got p to the first and p cubed, so my common denominator has to be p cubed. All right, let's look at number 2. My first denominator is p, and my second denominator is the family p minus 7. So this is one of those situations where there's just no option. We have to have a monomial p in our common denominator, and we have to have the family p minus 7. So our common denominator has to be p times p minus 7. Number 3, I think I need to factor first. I see an easy trinomial there, x squared plus 5x plus 6 can be factored into x plus 2 times x plus 3. Keep in mind that this squared right here means that I have 2 of these. So my first denominator is x plus 2 times x plus 3. My second denominator is x plus 2 times x plus 2. Okay, here's where people start to get confused. Let's look at the family x plus 2 first. My first denominator has one family of x plus 2. My second denominator has 2 families of x plus 2. Therefore, my common denominator has to have 2 families of x plus 2. And then my first denominator also has a family of x plus 3. So my common denominator needs to have that family of x plus 3 in it as well. You could certainly rewrite this as x plus 3 first and x plus 2 quantity squared second. The order doesn't matter. Multiplication is commutative. All right, last one in this section. X squared minus 36, that is a DOS. So I'm going to go ahead and factor that into x plus 6 times x minus 6. And 7x minus 42, that has a GCF of 7. So if I pull that out, that's going to be 7 times x minus 6. Okay, so now I look at my 2 denominators. I've got x plus 6 times x minus 6 in my first denominator, and I've got 7 times x minus 6 in my second denominator. Let's just look at each part separately. Let's start with the family x plus 6. I have one family of x plus 6 in my first denominator. I don't have any x plus 6 in my second denominator. Therefore, my common denominator is going to need one family of x plus 6. My first denominator has one family of x minus 6. My second denominator has one family of x minus 6. So my common denominator needs one family of x minus 6. And then the only thing that's left is in the second denominator, I have a 7. I already took care of the x minus 6, but I have a 7. So my common denominator has to have a 7 out front as well. Let's try some examples where we're actually going to do some addition and some subtraction. Number 1, first we need to determine our common denominator. We've got a 7. I know that needs to be there. First denominator has x squared. Second denominator has x to the first. Third denominator doesn't have any x's. So that means that I'm going to need at least an x squared in my common. Second denominator has a y. Third denominator has a y cubed. So I'm going to need at least a y cubed in my common denominator. So now that I know that, what I'm going to do is I'm going to rewrite this problem as 3 new fractions. And they're all going to have 7x squared y cubed as their denominator. And then it's just going to be my job to figure out how I need to change my numerators appropriately. So my old numerator here was just 7x squared for my first fraction. Now I have 7x squared y cubed. So it looks like I have to multiply top and bottom by y cubed. So this numerator is going to become 3y cubed. My second denominator, I just had x to the first, y to the first. So it looks like I'm going to have to multiply by the 7 and by an x and by a y squared in order to make my common denominator. So I'm going to multiply the top by a 7 and an x and a y squared. So 4 times 7, that's going to give me, or I'll just write it like this first and then we'll clean it up in the next step. 4 times 7x y squared. Right here, I just multiplied by that y cubed. And then my last one, I just had y cubed for my original denominator. Now I've got 7x squared y cubed, so it looks like I'm going to have to multiply top and bottom by 7x squared in order to make my new numerator. So I'm going to have 5 times 7x squared. Okay, so now let's do a little bit of simplifying here. My common denominator is going to be 7x squared y cubed. So my first term is that 3 times y cubed. That's just 3y cubed. Then I've got my minus sign. And then I have 4 times 7xy squared. That's going to be 28xy squared. And then I've got 5 times 7x squared. That is 35x squared. And notice my numerator has 3 different types of terms, so there isn't anything alike here that I can combine. So I'm done. This is my final answer for this problem. Next example. My first denominator is just an x. That's a monomial. My second denominator is a family of x plus 4. We had an example like this in our table on the previous page. So my common denominator has to have a monomial x, and it has to have a family x plus 4. And I'm also just going to chop slash that. I'm going to turn my subtraction into addition. It's always easier with rational expressions to add instead of subtract. So now I'm going to do exactly what I did in the last problem. I'm going to make 2 new fractions that I'm going to be adding together here with my common denominator. And I'm going to figure out what do I have to do to make my new numerators. So my first problem, or my first fraction, my original denominator was just the x. So I need to multiply by x plus 4 on top and x plus 4 on the bottom. So 5 times x plus 4 is going to be that new numerator right there. My second denominator, I had the x plus 4 family, so what I have to multiply by here is the x. So negative 3x times x there. So now let's clean this up a little bit. X times x plus 4. I have to do distributive property with the 5, so that's going to be 5x plus 20 plus negative 3x times x is going to give us negative 3x squared. Okay, the only thing I don't like about this is we always want our terms to be in descending order. So let's rearrange these. We're going to put our negative 3x squared first, our positive 5x second, and our positive 20 third. And our denominator is x times x plus 4. And that is going to be our final answer. All right, number 3, last example for today. Factor first. I've got a DOS here. X squared minus 25 can be factored into x plus 5 times x minus 5. And I've got a GCF in my second denominator of 2. So that's going to be 2 times x plus 5. We always want to factor first so that we can see if we have anything in common before we determine our common denominator. So now what I see is, if my first denominator is x plus 5, x minus 5, my common denominator is going to have to contain x plus 5, x minus 5. There's no choice about it. My second denominator, I have that family of x plus 5, which I already have in my common denominator. I don't need 2 because the first one has 1, the second one has 1, so my common denominator just needs 1. But I have that monomial of 2, so I need that as well in my common denominator. All right, now let's make our 2 new fractions. Both of them are going to have our common denominator of x plus 5, x minus 5. And now we just have to figure out what are we doing to change the denominator. So what do we have to do to change our numerators? All right, the first denominator, we had the x plus 5, x minus 5. So it looks like the only thing here that's different is we have to multiply by 2. So just 2 times the x there. And then in the second, we had the 2 and the x plus 5, so the only thing different here is we have to multiply by the family x minus 5. Okay, now we can go ahead and clean this up and combine it over our common denominator. 2 times x is just 2x. Here we've got distributive property. 3 times x is 3x. 3 times negative 5 is negative 15. And we do have some like terms right here that we can combine together. 2x plus 3x gives me 5x minus 15 over 2 times x plus 5 times x minus 5. And this is the first time since we've been doing these problems that we are actually able to factor our numerator a little bit. Now that we have our new numerator, there is a GCF that we can take out. We could take out a 5, and then we'd be left with 5 times x minus 3 over 2 times x plus 5 times x minus 5. Sometimes if you can factor your new numerator, you can do some reducing. But in this case, we don't have any families that are the same. So this will be our final answer.